I'm making some LED ornaments for Hack the Holidays. This first printed circuit board has 9 RGB flashing LEDs. They're all driven by a single coin cell. The only other component in the circuit is a power switch. Here you can see the coin cell on the back of the circuit board, and on this front side you can see the 9 LEDs. There's the coin cell, and there are the 9 LEDs. Each LED has a little circuit inside it that allows it to do all the flashing. So I just turned it on and you can see that it's changing colors. Each LED is independently doing its own thing. And this is a fairly slow changing color scheme. I have some other LEDs that change much quicker, but this particular circuit board, I put also slow LEDs on there. They probably all have the same circuitry inside, but due to slight differences in the timing and the size of the individual capacitors or whatever they're using for timing control, they actually turn on at slightly different times, and eventually it becomes quite a random pattern. The colors aren't coming through all that well through the camera because they're kind of saturating the pixels in the camera. But one thing that is kind of noticeable to me anyway is that the blue colors are a little bit dim, and that might be because the voltage in this battery is a bit low. Okay, let's have a look at one with a slightly faster LED flashing rate. This looks pretty cool when you first look at it, but I guess after a while that flashing might get a little annoying if you're looking right at it. But these are going to be ending up in 3D printed housings which mute the colors. Here's a bell-shaped housing that allows the circuit board to slide right in, and we can turn it on before we pull it all the way up. In this case, the LEDs are only on one side, so one side looks like a bell and the other side looks like a flashing light inside the bell. And this one is using those slow flashing LEDs. Although the housing is yellow, the actual colors of the LEDs don't change due to the plastic, so the colors actually come through even though the camera doesn't capture that very well. Okay, let's have a look at one with 2 cards in it so that the LEDs are on both sides. Still a bell shape, but slightly bigger. And as you can see, we've got the lights that are flashing a lot faster. And I can give it a spin just to see what that looks like. Speaking of spinning, I designed a different circuit board that can do the spinning for me. You can see this circuit board has a slot for a motor, and the shown on the left is one that's assembled with a motor. So on this card we also have a coin cell driving the whole card, and you can see the motor here is soldered right to the card with the power terminals and everything. There's no wires needed, it's just soldered right in. This side of the card also has 4 LEDs, as you can see in the corners. On this side of the card we have the circuitry that drives the motor, and we have a power switch for the whole card. Then there's 4 LEDs on the sides instead of the corners. The big chip here is a 14-bit binary counter with a built-in oscillator. Below that we have an 8-pin H bridge so that we can drive the motor in either direction. And at the bottom is a dual inverter delay circuit. The clock frequency is set by an RC, and we can also select different binary outputs with jumpers. The motor is simply strapped in with wire and soldered in place. The clock chip dictates the time between motor activations, and the delay circuit dictates how long the motor is on. The clock chip and the delay circuit feed the H bridge, which dictates which direction the motor is going to turn. I flattened the end of the motor axle and tied some spider wire fishing line in a Snell knot, and I added a drop of glue for insurance. When the motor armature starts to turn, it generates torque which winds the fishing line up in one direction, while at the same time the torque applies a spinning motion to the card in the other direction. When the motor stops, the fishing line unwinds, keeping the card spinning in the same direction it was going. Eventually the fishing line is completely unwound, but the momentum of the spin continues winding the line up in the other direction, and it will continue to oscillate back and forth until the motor kicks in again and decides to wind it up in one direction or the other. It's pretty neat that we can create all this chaos with just a couple of really cheap chips and a very low voltage motor. I've been playing with this thing for quite a while, and the battery shows no sign of dying. Okay, I'm going to hang it properly and just see what that motion really looks like. If you look closely, you can probably see when that motor starts up, it sort of jiggles a bit. The motor doesn't run for long though, it's less than a second. But it obviously winds up the line quite a bit in that time. The short on time is definitely contributing to a longer battery life. Here I'm showing some of the 3D printed ornaments that I'm using to house the LED cards. So far there's some bell shapes and some star shapes, and a couple of different colors. This card is not assembled, but you can see the motor slot. Here I've added a 3D printed star to the circuit board. The added mass makes a huge difference to the timing. But I like that it's going slower. This circuit actually allows me to play around with the timing a lot if I want to. But as long as it's moving or moving once in a while, I'm happy with what's going on. Ambient lighting also makes a huge difference to how it looks. The star is actually white, but it's tough to get the camera to capture the star and the LEDs at the same time properly. At least it looks great in person. Of course, we have to see what they look like on a tree. This one is just starting to come together, but it's starting to look good just in time for Christmas. I'm not sure what Nugget the cat thinks of all this, but at least he's checking it out. I think I'll wrap it up there since it's Christmas Eve. It's been a fun little project, and I'm glad it came together in time for Christmas. I hope all of you have a happy holiday season and best wishes for the next year.